For an AC circuit of this nature, we have our instantaneous current, I. Current at an instant. To be given as I naught sin what? Omega t. Right? So this I is the instantaneous current. Current at an instant of time. Let's say at this point, or this point, or this point. Why I naught is what we call what? Okay, let's finish up. We know that omega is what? This angular velocity, right? Can also be written as 2 pi f. So we can say that I equals I naught sin what? 2 pi f. And as a matter of fact, you wonder, why do we use sine? Why not cosine? The AC circuit takes a sine wave. Do you get it now? This is a sine wave from your mathematics. You should have done sine wave, cosine wave, and all that. So this is a sine wave. So we have, so it takes a sine wave. So to make a circle, and you know a complete circle is 360, right? I know you'll get it. So in this case, we said where I is our instantaneous current, right? I is instantaneous current, and I naught is our what? Peak or maximum current. Then we know that omega is our what? Angular velocity. Our F is our what? Frequency. And T is the time. Is that not it?
Yes.
Alright, so take note of this. I equals I naught sin omega t. So the current at an instant, the current at this instant, or this instant, at any instant in this AC circuit, or in your setup, is always given by the peak current multiplied by the sine of the angular velocity times what? Times time. I think that makes sense. So your omega is also same as 2 pi f, and f is a what? Frequency. At the same time, you can also get the voltage. So also your V now is also given as what? V naught sin what? Omega t. Please take note, that's angular velocity, omega. So where omega is same as what? 2 pi f. So that gives us V naught sin 2 pi f t. I think that makes sense.
Yeah.
So again, where V is what? Instantaneous voltage. Instantaneous voltage. V naught is our what? Peak voltage or maximum voltage. This omega is our angular velocity. F is our what? Frequency. And T is our. So let's take note of that. I think that makes sense.
Yeah.
Alright, so let's just take yes. Instantaneous current. Yes. I said when we say instantaneous means at an instant. At any point here. Current at any point here. Instant. So we can calculate current at any point. Do you get that? I can calculate the value of the current at this point. That's called instantaneous. At any instant. Do you get it now? So peak is the maximum. So if I should ask now, although this should be similar, they should be of the same. This is where you get your peak. Is that not it? That's the highest level. Peak, that's maximum. Alright. Why this one is the minimum? Or the least. Do you get it now? So this is our mass or peak. This is our zero. Is that not it? This is zero. And this is our minimum. I think that makes sense. All right. So let's take for instance now. You have to, if you are given that, let's take an example. Given that V equals 900 into sine omega t, and we have to find the peak voltage. So what's the peak voltage here? The peak voltage is what?
900.
Good. So our peak voltage is 900 volts. Take note. Do you get it now? If you also give, that's just it. That's the V naught. If you're also given that your I is 0.25, let's say sine omega t, you have to find peak current. What's your peak current?
0.45.
So that is I naught. So peak current is as I naught, which is what? 0.25 amperes. I think that makes sense.
Yes.
So now you know what your peak voltage is and what the peak current is.